Hey everyone, Professor Hank here. Today we're going to be talking about class copy constructors in C++. We'll talk about why your classes need them and how to implement them. So to start with, we need to understand this concept known as memberwise assignment. And that concept says that the equals operator can be used to assign the data of one object to another. Or you can initialize one object with the data of another. So remember, initializing means that you assign and define at the same time. So by default, each member of one object gets copied to the counterpart in the other object. So let's take a look at that by creating a class, and we'll call this class foo, and we'll simply have in this class a private integer variable, which we'll call x, and then we'll have a default constructor, which will initialize x with 0, and then we'll have a set and get method. So we'll have one mutator called set, and that will simply assign to x its argument, and then we'll have one accessor named get, which will simply return the contents of x. All right. So when we talk about memberwise assignment, we're talking about something like this, where we could say foo f, and then we'll assign to f some value, say 88. Now we can initialize another foo object with the contents of f. So initialize g with f. So what's going to happen here is we're going to have memberwise assignment. So f's x is going to be assigned to g's x, right? So this is what's going to happen. So when I do cout g.get, we're going to see the 88 because the contents of one x were copied to the other. Okay, now this is no problem in this scenario, but imagine a scenario where we decided we were going to use dynamic memory allocation instead. So that would mean that we would have a pointer. So that means in our constructor, we'd have to dynamically allocate a new integer, and then we'd have to assign to that integer value. And so then our set method would need to do something similar. X pointer equals I, and then return star X pointer. Okay, now what's going to happen here? All right, what's going to happen is that both foo objects, when we do this initialization here, are going to end up pointing to the exact same integer variable. Because remember, you're doing memberwise assignment here. You're copying the contents of one x pointer to the other. So what that's going to end up having happen is that both pointer variables are going to contain the same memory address. And therefore, both of the foo objects are going to refer to the same variable. So now if I was to come here and I was to change the g object's integer to say 33 by using that set, right? The behavior you might expect, you would think is, oh, well, only the contents of the g object, only its integer variable is going to change. That's not the case, right? Because as you're about to see, we'll do g.get and we'll do f.get. Since both objects point to the same integer, when I set g's variable to 33, I'm also assigning f's integer variable to 33 because both f and g are going to be pointing to the same integer variable. When we did this initialization, it wasn't the contents of our new integer variable that was copied. It was the contents of the pointer, because with memberwise assignment, you assign the contents of each variable to the counterpart in the other object. So let's see that. Okay, see how they're both 33? And if that wasn't bad enough, you also have a memory leak here because when g was instantiated, it created its own integer variable, right, using that dynamic memory allocation here. Then we copied the contents of f's x pointer, overwriting g's x pointer, thereby losing the memory address of the dynamically allocated integer variable that g created. Okay, so this is bad. And so this is going to be something we need to avoid. And we're going to avoid that by making a class copy constructor. So class copy constructor is going to have the same name as the class. It is a constructor after all. And then we're going to have a special type of parameter. And that parameter is going to be a constant foo reference. And I'll call it P. And so what's going to happen is that this F object will be passed by reference to the copy constructor. So once that's happened, we can then manipulate the F object. So when you have a copy constructor, one object is going to get access to the other object's private stuff. So what do I mean by that? in my copy constructor here, I'm going to dynamically allocate my new integer as before, but instead of having that memberwise assignment stuff happen, we're going to be doing some copying through the copy constructor. When you define a copy constructor, the memberwise assignment gets set aside and you execute the logic in your copy constructor. So this right here is our copy constructor, and this will execute instead of the default constructor. So this thing executes instead of the default constructor. Once we've dynamically allocated our new integer variable, we'll assign to that integer variable by dereferencing the pointer. Right? Remember, when we dereference a pointer, we're saying go to the memory location whose address is in the pointer, and we'll assign to it the contents of the integer variable that is assigned to the other object's pointer. When we say food g equals f, f is passed by reference to the copy constructor, and so now we can access f stuff. So in here we can say p dot get, access its accessor, that will return the value stored in its dynamically allocated integer, and then assign that to the dynamically allocated integer that belongs to this object. Okay, and so in that way, we're going to have two separate foo objects with two separate integers, and we preserve the contents of each individual pointer. So now when we run this, you're going to see that there are in fact two separate integer variables. Right? There's the dynamically allocated integer that was created for f as a result of its default constructor. We set that integer to 88. Okay, that's what we did right here. And then when we created our second object, our foo object named g, but initialized it with f, that triggered this copy constructor, which created a whole new integer variable for g, and then copied the contents of f's integer variable by using its accessor. And then we placed it inside of g's integer variable by dereferencing g's pointer. Okay, so one last thing with this, and that is that this initializes, right? This is initializes g with f, all right? But you can also invoke the copy constructor by doing this. This means the exact same thing, all right? So both of these are exactly the same. Semantically, the meaning is exactly the same. And in both cases, memberwise assignment is avoided. All right, so now you know why you need copy constructors for your C++ classes and how to implement them.